Okay, guys, I think we're in pretty good shape here. We finished the first two topics of 5 topics. This video, we're doing topic number 3, finding zeros of a polynomial. And it's something that's probably familiar to you. How do you find a zero of a polynomial? Basically, you want to write it in factored form. And this is talking about real zeros right now. Okay, 0 or root. Oh, shucks. Found my first typo here. There should be a space there. Okay, 0 or root of a polynomial is a value that makes the function equal to 0. So basically, it's the x-intercept, right? Remember when we had x-intercept, we said, okay, where's going to make the y equal to 0? That's your x-intercept. The x-intercept occurs at the zeros, or the roots of the polynomial. Okay, so one way to find the zeros of a polynomial is to factor it. That's because if you can write a polynomial to look something like this, f of x equals to x minus some number times x minus some other number times x other number. And, you know, maybe you have more. Maybe you have more. I don't know. More generally, you could say x minus a1, x minus a2, blah, blah, blah. Whatever it is, however many you have. Then, once you write it out like this, right? Then these guys are the things that make it 0, right? If x is a, then you'd be multiplying by, this thing would be 0, and you'd be multiplying something by 0. So if x was b, this would be b minus b, that's 0. Or if c, then c minus c, that's 0. So that means a, b, and c would all be the things that make it 0. So those are the roots of the polynomial. And these are real roots because we're assuming these are real numbers. That's basically how you do it. So you factor it, tells you what the roots are. Okay, now there's something else called the intermediate value theorem. Intermediate value theorem. This thing is going to show up in calculus too if you end up taking calculus later. Well, it's really just common sense. It has a kind of fancy name, but it's really just common sense. It says if a polynomial changes signs, either from positive to negative or negative to positive, then within that change, it must have passed through the 0 at some point, right? Let's just think about that. It's really obvious, right? If you have a graph like this, and here's your polynomial, starts off positive, and then at some point it goes negative. So if you take some interval, let's say this is the A, this is the B, right? At some point in between, if it's going to go from positive to negative, then it must have passed through 0 to get there. And that's all it's saying. And same thing if you started at some point negative and at some point positive in between, it must have passed through 0. That's what the intermediate value theorem says. Okay, here's the more mathy way to say that exact same thing. It says, okay, let A be less than B. Okay, that just means A is like to the left of the B, right? And they're both real numbers. That's all this is saying. This is fancy math language to say A and B are real numbers. If f is a polynomial function, then the f of a, that's the value of the function at a, and f of b have different signs. So they're, I think that's a typo here too. That's spelled wrong, sorry. Okay, so they have different signs. Then there's some c in between, so some c in the interval where it hits 0. And that's basically what I explained to you in this little diagram here, right? The little picture. Okay, let's try question 7 to 10. Okay. All right, so 7 and 8, first of all, we're just finding zeros of the polynomial. And to do that, we're going to have to do a little factoring. This will be a good refresher on factoring too, especially factoring by grouping, which is something that, at one point in my life, I remember forgetting and then having to relearn it. Actually, I think I relearned it when I had to start teaching it. So, yeah, that's how it goes. Okay, number 7. Find all real zeros of the polynomial. So f of x is equal to x cubed minus x squared minus 6x. So first thing, obvious thing to factor out is the x. They all have x terms, right? So this will be x squared minus x minus 6. Okay, and this is one of our things that we learned how to factor back in like middle school. Here you got an x and an x. Okay, I want this end result to be negative. That means one of them should be positive, one of them should be negative. They should multiply to 6. So it's looking like 2 and 3, right? 2 and 3 multiplied to 6 with a difference of -1 here. Here, -3 and +2 is -1. Yeah, so that's what makes it work, right? And if you want to double check, you can FOIL this thing out and you'll see that you end up with x squared minus x minus 6. Okay, so that means what are my zeros? What are the zeros? Zeros are x equal to 0, because that would make this whole thing 0, right? Or x equal to -2, or x equal to +3. Those are the 3 things that would turn this whole result equal to 0. And if you want to, you can check by plugging that in. 0 is obvious, right? If I plug in 0, it's going to be 0 minus 0 minus 0 is 0. So that's obvious one. Negative 2 is going to be negative 248 minus 4. Yeah, minus 4. And then minus negative 6 is positive 12, plus 12, yeah. Negative 8 minus 4 plus 12 is 0. So yeah, that works too. Okay, you can check like that, or you just trust that we did it correctly. Okay, number 8. Number 8. Let's clear the books before we start, so we get more space to see this thing. Okay, here we are, number 8. We've got f of x equal to, okay, 2x cubed minus 3x squared plus 4x minus 6. And you ask yourself, oh, shucks. I don't see an obvious factoring here. I've got like 4 terms. What am I going to do? Well, this is where we just try grouping. And when you group, there's only a few options you have, right? You could either group by these two things as they are, or you could maybe rearrange things by like maybe this and this and this and this. But I think the most obvious choice here is just group where they're at. So just think about this group here and factor that group and factor them separately. So I can rewrite this as, if I'm going to factor something for this group, what do they have in common? They have x squared in common, right? And what does that leave you with? It leaves you with 2x minus 3. Okay, now let's do the same for this group. What can I factor here? They looks like they both have a 2 in common. So if I factor out 2, it's going to give me 2x minus 3. And oh, look! Wonder of wonders! These guys match up, right? 2x minus 3. Oh, that was a poor color choice. Let's use, what goes with blue? Yellow, I think. 2x minus 3, 2x minus 3, right? And since they're the same, then you can do this second little trick and just kind of do this factoring. Here, you're going to take the x squared plus 2. Oh, I should change colors here. You take the x squared plus 2, and both of those have in common being multiplied by 2x minus 3, so you can factor it that way. All right, so there you go. Okay, now, looking at this thing, if it's not obvious to you what the zeros are from these individual factors, then you can actually just try to solve them. So here's x squared plus 2. When is that equal to 0? And the answer is going to be never, because watch what happens. X squared equal to negative 2. There's no real valued number that squared gives you to negative 2, right? So there's no solution from this set. What about from this set here? What about this guy, 2x minus 3? Well, just solve it. I mean, you might see it mental math, but if you don't, that's okay. Just write it out. Set it equal to 0 and then solve, right? 2x, add 3 to both sides, equal to 3. Divide by 2, it's 3 halves. So if x is 3 halves, I don't know, I keep doing that to me. If x is 3 halves, then that's going to turn this piece 0. 0 times anything is going to be 0. So you have one real root, which is just x equal to 3 halves. And that's it. That's all the real zeros. There's only one real 0. That was number 8. Great. Okay, now moving on to number 9 and number 10. Number 9 and number 10. Okay, so now we're going to apply the intermediate value theorem to show that each function has a real 0 in the specified interval. And then once you do that, we're going to approximate. We're going to try to narrow it down to where exactly that root is. And you could do it to however, you can do it however close you want to. You could even train a computer to do this for you really quickly, write a little program for that. But we're going to do it by hand, so we're not going to get to too fine detail. We're only going to go to one decimal place. So let me show you how this works. Do it with number 9. Okay, first thing is to show that there is, in fact, a 0 within this interval from 2 to 3. And so how do we do that? We're going to do f of 2 and f of 3. And what we want to show is that they're different signs. If they're opposite signs, then we say, by the intermediate value theorem, there must be a real 0 in between. Okay, so what is f of 2? That's going to be 2 to the 4th minus 2 to the 3rd minus 10. Okay, 2 to the 4th is 2, 4, 8, 16. 2 to the 3rd is 8 minus 10. That's 16 minus 8 minus 10, which is negative 2. So the key here is it's negative. Okay. Now, if f of 3 is positive, then that means we have on our hands a root in between somewhere, right? So f of 3 would be 3 to the 4th. That's 81. Minus 3 to the 3rd is 27 minus 10. So I've got 81 minus 27 minus 10. You know what? I'm not even going to bother finishing this calculation. I'm just going to say that's something that's bigger than 0. No, you know what? I'm being too lazy. I'm going to confuse someone by my not writing out the calculation. So you know what? Let's just do it. Let's just stop being so lazy and do it. I think I told you guys before, I'm just not a fan of computation, but that's 44. I just cheated. Okay, 44. So what happened? Look, this guy's negative. This guy's positive. So what you say is by the theorem, we call it IVT for short, intermediate value theorem, there exists a 0 between 2 and 3. Somewhere between 2 and 3. And just think about it, right? Just think about what's happening here. This is without knowing anything else about the polynomial. I just know that at 2, so at the position 2, here's 1, 2, I'm at negative 2. Okay? And then at the position 3, I'm at positive 44, which is actually off my picture. It's like it's way above where I even drew it. But that just means that since I have a continuous curve, right? Well, I don't know something. To get to that point, I must have crossed through at some point there, right? I must have crossed through the axis to get there, and then continue on. Okay, now it says to approximate to 1 decimal place. So how do you do that? Well, you basically do the same thing with the intermediate value theorem again, but you just try to find where it first turns from negative to positive, right? Now, looking at my numbers, negative 2 is a lot closer to 0 than 44 is. So my intuition says I should try to stick close to the negative, to that value. Right? So stick closer to the 2 than to the 3. So what should I do? I'm going to plug in 2.1 and then plug in 2.2, etc., 2.3. All right, until I find the first sign change. Now, because I'm feeling lazy, I'm going to show you guys a little trick with a calculator here. I'm going to use it's a picture of my son holding the, so many games. Sorry, guys. Let's open up the calculator here. Oh, not that one. Okay, here we go. So, I should have prepared this in advance because now I see all my embarrassing pictures. Okay, so here I'm looking for x to the 4th minus x cubed minus 10, right? So here's using the Desmos calculator. I'm just going to type that in because this is kind of a tedious computation otherwise. X to the 4th minus x to the 3rd minus 10, right? Is that what it was? X to the 4th minus x cubed minus 10, yeah. Okay, so I'm going to plug in x equals to, what is it equal to? So let's just do a check for what I had earlier. When it was 2, I should have had negative 2. Yeah, and that's right. You see the negative 2 pop out? Okay, so what about 2.1? Okay, now it's 0.01871, so still positive, right? Okay, what about 2.2? Okay, still, oh, wait a minute. What happened here? 2.2. Oh, I'm sorry. Oh, yeah, right here. Okay, so actually, it turned positive already. Right? So at 2.0, I was negative 2. At 2.1, I'm at positive 0.1871. So that means it's between 2 and 2.1. That's where my root is. So that kind of answers my question right there. Let's see. Here. So f of 2.1 is greater than 0, whereas f of 2 was less than 0. So the root is between 2 and 2.1. So that's within 1 decimal place of the true value, right? We've located it within 1 decimal place. So there you go. And you can get further accuracy by just plugging in closer and closer numbers. You could go to 2 decimal places and do 2.01, 2.02, or whatever it is. 2.03, 2.04, 2.05 to figure out where exactly it first changed. Okay, now we're going to go to number 10. Same process. We're checking if there's a 0 between 1 and 2. And let's do f of 1 first. That's 1 to the 4th minus 1 squared minus 2 times 1 minus 5. Okay, that's going to be 1 minus 1 minus 2 minus 5. 1 minus 1 is 0, minus 2 minus 5 is negative 7. Okay, f of 2, that's 2 to the 4th minus 2 to the 2nd minus 2 times 2 minus 5. That's 2, 4, 8, 16 minus 4 minus 4 minus 5. Okay, 16 minus 4 is 8 minus 5 is 3. So here I went from negative to positive, right? So again, by IVT, there exists a root or 0 between these two values at input, right? Between 1 and 2. Okay, so we're going to do the same thing. X to the 4th minus x squared minus, what was it? 2x minus 5. 2x minus 5. Okay, and then we're checking at x equal to, let's just double check our work here. X equal to 1 is at negative 7 and 2 is at positive 3. So we see the sign change right there, right? Now this time it looks like the positive 3 is closer to 0. So let's start from that end instead. So instead of 1.1, we're going to start at 1.9. Okay, at 1.9, I'm 0.622. Okay, here, let's do it like this, actually. Oh, no, yeah. Let's do it like this. Okay, so 1.9, I'm at 0.62. At 1.8, negative. Okay, right there's a change right here. Right there's a change. So 1.8 is negative, right? And 1.9 is positive. So that means the change, or the 0, occurs between 1.8 and 1.9. So there you go. So f of 1.8 is less than 0. F of 1.9 is greater than 0. So that means the 0 is between 1.8 and 1.9. Basically, we just reused the intermediate value theorem, and we just did a finer comb, right? We went by first decimal places instead. So there you go. That's it, guys. That's it.